Okay, I think I'm live. Let me just check if I'm live or not. Just give me a second. Yeah, I think I'm live. Let me share my screen. Okay, I think my screen is visible, right? Okay. Let me just read the problem statement. Given two sorted zero indexed integer arrays, num1 and num2, as well as an integer k, return the kth smallest product of nums1 of I and nums2 of j. Okay, can you just zoom it in? Okay. Uh, nums1 of I into nums2 of j, where okay, the problem statement is pretty simple, but the solution is not going to be easy because it is going to go out of bounds if we will just use the brute force approach, right? The problem statement is pretty simple. I just have to like take the product of these two elements. The first element with this, like I just have to multiply both the arrays, both the array elements, and give the kth smallest element as our answer. Why the brute force approach is not going to work? Because first of all, we have to like calculate all the products of these two arrays, and after that I have to just sort that array because it is not going to be sorted. Suppose the array is, let's suppose the array is something like -1 comma 2, sorry, -1 comma -3 comma -1 comma 0, and the another array is, let's suppose, 2 8. Okay, this is the array, let's suppose. And yeah, what is going to be the resultant solution? 3 to a 6 minus 6 comma -2 comma 0 comma uh, 8 3 are 24 minus 24 comma 8 1 ja 8 minus 8 comma 0. So after sorting, what is going to be our answer? Minus our final array, minus 24, minus 8, uh, minus 24, minus 8, minus 6, minus 2, and 0. Yeah, so this is going to be our array. So first of all, we have to just take the multiples of both the arrays. So it is going to take o of big O of n into m, and we also have to sort this array. So it is going to take log of n into m. So the overall time complexity will become big O of n into m into log of n cross m. So yeah, this is going to be our time complexity. And as you can see, the length is like 5 into 10 to the power 4, which is going to exceed our like like time constraint. Okay, still, if I want to code the solution, I don't want to, because it's like simple that, okay, let me just code the solution. Okay, rather than just thinking long product. Okay, let me just make this like this. Okay, long product. What I have to do, I just have to take products of all the arrays, right? uh, int I is equal to 0, I is smaller than, sorry, int I is equal to 0 comma j is equal to 0. Okay, for int I is equal to 0, sorry, while I is smaller than n and j is smaller than m, we have to iterate through array till that time. Also, let's initialize the value of n and m. n is equal to nums 1 dot size, comma m is equal to nums 2 dot size. Okay, yeah, we just have to take products of both the arrays, right? Let me initialize it by long. Okay, now what? Just take the product of these two. Long temp is equal to uh, nums 1 of I into nums 2 of j. Okay, just push back this product dot push back temp and I plus plus j plus plus I plus plus comma j plus plus. Okay, now while I is smaller than n, do the same thing or just add the elements in this, right? Or no, first of all I have to see, this is a brute force approach. Okay, I don't have to code the solution. It is not necessary to code this solution, or let's just leave it for int I is equal to 0, long I is equal to 0, I is smaller than n, I plus plus. Okay, again int long temp is equal to nums 1 of I. Okay, for int I, int j is equal to 0 to j is smaller than n, j plus plus. Okay, now what? uh, just product dot push back temp into uh, product dot push back temp into nums 2 of j. Okay, great. And I don't have to keep a variable. Okay, yeah, I did this. I just have to initialize the value of I and j. Int n is equal to nums 1 dot size, comma m is equal to nums 2 dot size. Okay, great. I is equal to 0, I is smaller than n, I plus plus. Just add the product of these two. Yeah, it is not a big deal. Okay, now sort the entire array. Sort product dot begin, comma product dot end, return product of k minus 1. That's it. I think this should work for few cases because this is not the optimal solution, right? Let me just see if this is working. There is some error or what? Yeah, it worked. See, it worked for few cases, but it is not work. It is not going to work for all the cases because, as I told you, that there is going to be some cases or many cases where this time complexity will make a issue. So let me just submit this code. Okay, for the seventh case only, I got a runtime error. Why? Because yeah, 1 second. It was not because of that. Int product dot pushback signed overflow minus 1000 cannot be returned type end nums of j Perfect. Okay, let's just leave it. Okay, and let's talk on the optimal solution. These are just error giving for. Let me just do this. Okay, let's not run from it. Long product of pushback. Yeah, now it is working. As you can see in this test case also, it is working. So let's talk about the optimal solution of this code. Mm, As it is written in the question, I have to find the kth kth smallest product. Kth smallest product. So whenever I hear about this, whenever I get this k smallest, I think of something like binary search. Okay, so if I'm going to think about some binary search solution, I have to just think. Let me just bring my charger once again. Okay, let me just read the problem statement. Okay, great. Starting from the first element, I have to go check find the kth smallest, right? Rather than focusing on the kth smallest, what if I'll just take a range from for the solution? What if I'll just initialize a range which is it is going to be long, right? So it can be 1e10. Yeah, great. I can go from low this, high this, and I'll just shrink my search space according to the input. Uh, okay. Mm, The main idea is I'll just okay. Let me just write it out. Okay. Uh, I'll take. I'll just start from a search space, which is going to start from 1e minus 1e10 to 1e10. Okay, I'll just search, keep a search space in between this, and I'll just take the mid. And after taking the mid, I'll just count that uh, how many pairs of nums of I and nums of 1 and nums of 2 have a pair which whose product is smaller than the targeted product. I'll keep track of that, and after that, uh, I'll also keep track of the negative numbers, because for the negative numbers, the product is going to be 0, right? So let me just write it here. Okay, After this, I'll just count how many pairs are present from nums1 and nums2 whose product is smaller than the target product. Okay, yeah. So this is going to be my main approach, but the thing is how I'm going to find this. Okay, suppose the element is positive integer. Okay, suppose the element is positive, then so it's simple, like I'll just take a product with these elements and find the leftmost element. So I'll just have to take three conditions. The first one is going to be if the element is positive. The second is going to be if the element is negative. The last is going to be if the element is 0. Then what? If the element is positive, I'll just find the element, and if the if the element is negative, I'll just search for the leftmost element whose value is smaller than the targeted product. And if the value is 0, then all the elements is going to be greater than the, or if the target product is greater than 0, so all the product is going to be greater than 0, right? So yeah, I'll do that. Let me just code this solution, code this approach. Okay, the first thing that I'm going to keep it in mind is my search space. So long left is equal to minus 1e10 comma right is equal to 1e10. Okay, so this will be my search space from 1e10 to minus 1e10 to 1e10. Okay, and like binary search, uh, while left is smaller than right, I'll find mid. Long mid is equal to left plus right minus left by 2 plus 1. Okay. Mm, now what? I have to call for that function, right? If I have to count the pairs, count pairs in which I'm going to give the left element and mid element, right? So yeah, nums1 comma nums2 comma the mid element, these three given if this value is greater than or equal to k. This can be our possible answer, I can say. So high or right is equal to mid. Okay, and if this is not the case, I just have to shrink my search space. So left is equal to mid plus 1. Okay, and just return left at the end because we'll get our answer there only. Now the main thing is to write this code, write this function. The main body is to write this function, right? Let me just think again. I have two arrays which is sorted, already sorted, right? So starting from the leftmost element and just checking the elements, my search space is going to be between minus 1e10 to 1e10. Okay, I have to search for three things. If the element is positive, if the element is negative, then the leftmost element. If the element is 0, all the elements if target is greater than 0. Okay, suppose that target is the value of target is 5, then all the elements are like um, accepted. If the element is -1 also, so none of the elements are accepted, right? Okay, let me just write the code of this. Yeah, uh, long count pairs. I will take vector of int nums1, nums2. Okay, the main thing is I have to run this code for three things, right? The first one is the positive integers. So uh, I'll just write this code like mm, for auto element of nums1 if num1 is greater than 0, then I'm going to run a different loop. Else if nums1 is smaller than 0, then I'm going to run a different loop. Also else, which is nums is equal to 0, then I'm just going to check if check one more thing. I have to also take int target. So if the value of target is greater than equal to 0, uh, which is greater than equal to 0, just add the elements. mm, long pairs is equal to 0. Add all the elements of num2 in pairs, right? Pairs plus is equal to nums2 dot size. Okay, at the end return nums2. Okay, now I'll just have to, if the elements is positive, uh, if the elements are positive, what I'm going to do, I'll just look for the rightmost nums of 2, right? Let me just write it here. Look for the rightmost num2 element. Okay, and if the num1 is smaller than 0, then if the element is negative, then what? If the element is negative, what am I going to do? uh, in this I was looking for the rightmost element, and this I'll just look for the leftmost element, which is smaller than equal to the target product. Equal to the, which is smaller than equal to the target. Okay, also in this case look for the leftmost nums2 element, which is smaller than equal to the target. Okay, great. Okay, mm, and in this I'm just adding all the elements if the target is greater than 0. Okay, great. Now talking about a search space, if uh, the element that I am iterating over, I'll just start from the leftmost element. uh, long left is equal to 0, right is equal to nums2 dot size. Okay, now mid, I have to find the value of mid. Long mid is equal to just left plus right by 2. Okay, now while left is smaller than right, while left is smaller than right, I should write it here. Okay, I just have to check if the multiplication of both the elements, okay, if it is smaller than the target. So nums1 of left into nums2 of right, if it is smaller than equal to the mid or target. Okay, if it is smaller than equal to target, left is equal to mid, else right is equal to mid. Great. After coming out of this loop, I'll just write pairs plus is equal to the value of left, because I'm just finding all the left values, right? So I'll just add the uh, elements which are smaller than this. Okay, now what? For the right element, for the negative elements, I'll do the same. Long left is equal to 0, comma right is equal to nums2 dot size. Okay, and while left is smaller than equal to right, while left is smaller than equal to right, just find the mid, value of mid. Long I can write it int, don't need to write long int. Okay, int and mid is equal to nothing but left plus right by 2. Okay, now what? Check again if uh, the value of nums of I and left is equal to mid plus 1. Same goes here if the value of it is not left, it is element. If the multiplication of element into nums2 of mid is smaller than equal to the target, if this is the case, just give right is equal to mid. Okay, and if this is not the case, left is equal to mid minus 1. Okay, and at the end just add all the elements. Okay, nums 2 dot size minus left. Okay, great. Let me just dry run this code. If nums1 is greater than 0, element is positive, look for the rightmost element which is more than equal to target. Int left is equal to 0, right is equal to nums2 of size, while left is more than equal to right. Uh, yeah, while left is more than right, and int is equal to left plus right by 2, and element into. Okay, I have to change it to long right, long because after multiplication it may lead to some value. Okay, left is equal to med plus 1 and right is equal to med, pairs plus is equal to left. Okay, else if nums1 is smaller than 0, it is going to be element. It is going to be element. Okay, pairs 2 is equal to this. Else if it is equal to 0, if target is greater than 0, just add this and return the value of pairs. Okay, while left is more than equal to right, yeah, it is going to be, let's keep it left right only. Left is equal to mid plus 1, return left, the return type is long right. Just check if this code is working or not. Okay, external declaration. Okay, if long if long time limit exceed, let me check again for auto element. If element is greater than 0, int left is equal to 0, right is equal to nums2 of size, while left is smaller than right. And first of all, I'm checking for the positive elements. I check for the positive element. Its element is positive, while left is smaller than right. And mid is equal to left plus right by 2. If long left is equal to mid plus 1, pairs is plus is equal to left, right is equal to mid, pairs plus is equal to nums of 2 dot size minus left. Uh, okay, let me just again dry run this code only. Okay, let's take example of 6 8 and 2 4. Okay, let me just try run this code. Right minus left by 2. Is there any error? For decreasing, so I should write left is equal to mid plus 1 now. Okay, I think this should work now. Okay, runtime error. If, yeah. I also have to change it to long. Is it okay? Wrong answer. Okay. Hmm. Okay, okay. Let me check. Where is the issue? I'm starting from 1e10 to minus 1e10 to 1e10. I'm starting from left. Say, while left is smaller than right, long mid is equal to left plus right minus left by 2 if count pairs is greater than equal to k. Okay. Uh, I'll send mid. Right is equal to mid and left is equal to mid plus 1. Okay. Let me check for this one. Count pairs, long pairs is equal to 0 for auto element of nums of 1 if element is greater than 0, just go into this. Left is equal to 0, right is equal to nums to your size, while left is more than 0. Mm, okay. Pairs plus is equal to nums element is smaller than 0. Okay. Uh, while left is not equal to 0, if target is greater than 0, pairs plus is equal to nums to dot size. Okay. Yeah, it's right. Pairs plus is equal to nums to dot size minus. I'm adding 11. Okay, now I think this should work. It was just 11. Okay, I think this should work. Yeah, I wrote 11 instead of 1. Okay, yeah. So, and the basic wide idea was to just take the search the element from left, like from 1e10 to 1e10, and just keep incrementing the or keep decreasing the search space. So yeah, that's the whole idea.